Hello everyone. I'm Mohammed Muyadi. I work as an architect in Talentica software, and today we have with us Hemant, and he's going to talk about Dapr, which is a new way to build distributed applications. So Dapr is short form for distributed application runtime, I guess. So over to you, Hemant. You can
Yeah,
start.
thanks, Mohammed. So, hello everyone, and welcome to today's session. So, in this session, I'm going to talk about Dapr, and we will see how Dapr is changing the way we will be building our microservice application. So, my name is Hemant Sachdeva. So, I have a total experience of 13 years, and for past 5 years, I've been working on microservice-based application. So I have built various type of microservice-based application. I have built from scratch, uh, and I have even worked on projects which involve migrating monolith application into microservice-based application. Even I worked on a project which already is in microservice architecture, but they are facing different type of problems like scaling problem, security problem, or they probably have built a wrong microservice. So that kind of exposure I have in service world. Okay. So for past few months, I've been exploring this Dapr. So I've been learning and evaluating the Dapr. So this session is all about sharing my learning with you all. Okay. So let's start with the session. So if any one of you have already worked on a microservice based architecture, you are probably aware that there are various common concerns which developer either has to develop or they probably have to introduce library into their application. Uh, so I have listed down those common concerns here. There are more, but I have only listed down those concerns which I feel is the topmost concern, right? So in microservice, the very basic requirement is to enable service-to-service communication, right? That's a very basic requirement. So there are two type of communication, right, between the services. The first one is synchronous communication, and another one is asynchronous communication. Under asynchronous communication, there are so many patterns, but the most popularly used or famous one is PubSub. So PubSub stands for publisher and subscriber pattern. So in this pattern, one service publish the event, the other multiple services subscribe to that event. So when the publisher publish the event, the subscriber will get notified about that event. So this is the pattern. We generally implement this pattern whenever we are building application in microservice application, right? So at consumer side, we also end up building some sort of logic for routing, right? The routing, I mean, say if publisher is raising an event of type A, then at publisher side, we write a logic. Say if event is A, call method A, right? If event is B, call method B. So we end up writing such routing logic in our application, but this is not a consistent way, right? There is no standard of defining that routing logic, right? Even whole implementing PubSub is not a standard way of implementing that, right? See, if I am using RabbitMQ to achieve PubSub, right, I'll be using different sort of libraries. I'll be writing different type of code. But if I switch to say Kafka, again I'll be using different type of library. I'll be writing different type of code. So there is no consistent or standard mechanism to achieve PubSub or PubSub routing, right? So this is what uh, under asynchronous communication, right? Under synchronous communication, right? There is a problem of service discovery. So similarly, so we have service to service access control list. So under access control list, basically we write policies So we write a policy such that whether service A is allowed to call service B or not, right? So that kind of policy we write under ACL. Then we write custom logic for retries. Custom logic, or we include libraries to implement to achieve retries, timeout, circuit breaker, rate limit. Similarly, there are a bunch of common concerns. I'm not going to go through all of these, but I'm hoping you understand those concerns. So we have distributed tracing, we have metrics, then there is a state management, then secret management, then we have security. Under security, we probably have to implement auth 2.0 or mutual TLS for service to service communication. Then there is a central logging. Then there is a distributed locking, right? So these are bunch of the concerns which developer have to implement, right? When if the application is into microservice architecture. Okay? So let's look at very high level how we achieve, how we implement those concerns, right? Those common concerns in our application, right? So at very high level, what we do, we introduce a library, right, which enable communication correspond to the vendor, underlying vendor. Like in this diagram, I have included Java RabbitMQ library. So this library understands how to communicate with underlying vendor. In this case, is RabbitMQ. Similarly, there is a library for Kafka, which enable communication to the Kafka. Similarly, if my application wants distributed tracing, so there is a open tracing library. Similarly, for other concern, we include library correspond to that concern. Okay. So now on top of these libraries, there is a configuration layer. We configure this library according to our need, right? So if it is running in local environment versus if it is running in production environment, we probably configure it different, right? So also this layer enable communication. So if you see, there is a component. These are the application components. Application component uses this configuration layer, which enable communication the underlying vendor.
Right. Right.
So now, say if we look at another service, now the another service is written in Python, right? So if it is written in Python, then same approach we have to do again, right? We again search for Python-based RabbitMQ library.
Mm-hmm.
We include that library into our application. Then we probably write Python-specific configuration layer, which will be used by our application components, right? So you can assume if there is another service written in different language, we have to follow same approach. Okay. So if I have to highlight the problem with this general approach, the first problem is developer has to understand the library, right? He has to go through bunch of documentation to understand the library so that it can include in our application. Then someone has to make sure that library is configured properly so that it can run in production, right? So misconfigured library can misbehave in production environment. So someone has to make sure that even library we configure rightly configured. Okay.
Mm-hmm.
So during the lifetime of application, there may be a chances that we might be changing the underlying vendor. So in this example, if we are moving from RabbitMQ to AWS SQS, right?
Mm-hmm.
Then again, developer has to learn new library. He has to go through the documentation related to AWS SQS SNS. He has to reconfigure it, right? The whole release cycle, we have to follow it again. And it is not just a library. You are making changes to your application code as well. right? And in addition to that, so if you are using any library and that library gets deprecated, then you have to search for another library. And there are other concerns for those libraries, like you have to apply security patches. You have to make sure the library is up to date, right? And the main concern is, so if you move from one language to another language, right? So whatever you have done for one first language, that won't be reused in another language, right? So you have to repeat all these things same for that language.
Right.
So basically, there is no consistent way of implementing those common concerns. Okay? So this slide, I'm highlighting how Dapr is trying to solve these problems. Right? This is very high level approach. So if you see, so whatever the library we have included in our application, right, those library and the configuration, both now will be taken care by Dapr, right? If you see this box, so what I was highlighting in this slide, that whatever the library we have included in application to communicate with underlying vendor, now those library or those code, right, those code move to Dapr sidecar, right? So this box is nothing but a Dapr. So now Dapr is taking that responsibility of communicating with underlying vendor. Okay. So our application, so if our application need to talk to the vendor, it will talk via Dapr, right? So Dapr and our application can communicate via two mechanisms. So these mechanism is defined by Dapr itself, that HTTP or gRPC.
Okay.
Right? You can use either of these to communicate with Dapr. Okay? Then Dapr further communicate with the vendor.
So these are the only two protocols available for communication.
Yeah.
gRPC.
In Dapr, these are the
Okay.
These are the two communication protocol available in Dapr. I think that's intentional. They did that. Right?
Okay. Yeah, I mean these are the most popular ones, so I think makes sense.
Correct. Yeah, exactly. So as a pattern, this pattern is called sidecar pattern, and this is very famous pattern in microservice world. So in this pattern, there is a small application sits behind alongside your main application. So your application communicates with that sidecar for cross-cutting concerns. Right? So this sidecar pattern is very famous pattern. Okay. So this is similar to the previous one slide, but I have shown in context of Kubernetes. So in Kubernetes, so there is a concept of pod. So in pod, you can have a multiple container. So one container will be your application container, and the other will be Dapr container, right? So they get deployed in a same machine.
On
But
the
the
same
idea
pod.
is same.
On the same
Your
pod.
application, yeah, on the same pod, correct.
Okay.
But so idea is same. Your application will communicate with Dapr, and Dapr will further communicate with underlying vendor.
Okay.
Okay. So I have just discussed at very high level how Dapr is trying to solve the existing problem. So now I think let me introduce formally what the Dapr is. The Dapr stands for Distributed Application Runtime. So you probably by now already know this is not a library, or this is not a framework for any language. So this is a runtime. Okay. So this is a runtime built by Microservice, and it is an open source project written in Go language. Okay. So Dapr is a runtime which provides us essential components. Right. In previous slide, I have shown you library, but in Dapr context, they are not calling it as a library, but they are calling it as a component. So Dapr provides us essential components to build resilient microservices. Okay. And Dapr is only for microservice architecture. So if you are planning to introduce Dapr in say monolith application or modular monolith, probably it won't help much. So it's only for I guess only for microservice architecture. And also each component, right? Dapr provides us bunch of components, and each component is independent component. So whatever the requirement we have in our application, we use that component. And each component is codified using industry best practices, right? And because Dapr is the runtime, it become a language agnostic. It's not a library, it's not a framework. Then it become a language agnostic, and it is also platform agnostic. By platform agnostic, I mean that you can run Dapr in your local machine. You can run on Kubernetes or in any cloud or edge computing source, AWS, Azure, GCP. So this slide I have taken from Dapr website itself. So these are the components provided by Dapr. If you look at the middle here, so these are the components, reusable component, independent component provided by Dapr. The first component is service to service invocation. So this component help you, service discovery. Whenever you want to talk another service synchronously, then you use this component. Similarly, it has a state management component. Then there is a PubSub, resource binding, actor, observability, secret management, configuration, and distributed log. Okay. And at the top, it is showing that any framework, any language can use Dapr as long as that framework or that language support making HTTP API calls or gRPC API calls, right? So that's the minimum requirement from Dapr, that your application or programming language should be able to make API calls.
Correct.
Then this lowest layer is showing that it can run on any cloud. Now there need to be some mechanism with which Dapr needs to know which component your application is interacting with, right?
Okay, Hemant,
So
before
how Dapr comes
there
to
is
know
another
that?
question. So how big is the runtime in terms
Yeah.
of memory?
So runtime memory footprint, I'm not aware of that, but the total size of Dapr is very less. It's about 40 or 50 MB. Okay. But they claim their memory footprint at runtime is very less. But how less, how much, that even I have to go through the documentation and see.
Okay, fine.
But generally, if any application is claiming to be a sidecar, right, then their memory footprint is less normally, right? That's why they can they should able to run within your application.
Correct. Yeah. I mean, they are supposed to be of smaller size.
Yeah. So as I was explaining, so our application interacts with Dapr via REST endpoint call, right? Dapr somehow needs to know which component your application is interacting with. If you look at the structure of this URL, right, in the URL itself, there is a hint, right?
Okay.
There is a name of that component. If you see, if that URL starts with invoke, then it means the application is trying to use service to service invocation, right?
Okay.
So if it starts with publish, right, then it means application is trying to publish the event.
Okay.
If it starts with subscribe, then the subscriber wants to subscribe to a particular channel, right, and so forth. So this is how Dapr will come to know which component application is interacting with.
Okay.
So the design of each component is pluggable design. So I mean, how it is pluggable. So each component has exposed one single interface, consistent interface, right? And our application will only interact with that interface.
Right.
The implementation of that interface could be anything, right? So if you see in this, there is a state store, right? So that state store component probably have exposed one interface. here probably by interface, I mean this endpoint, right? What's the endpoint looks like, what's the payload, that's interface. But the implementation behind that interface, it can vary. So it could be your Redis, it could be Firebase, it could be AWS DynamoDB, right? Similarly, in case of PubSub broker, it could be RabbitMQ, Redis, or AWS SQL, right? So if you see the beauty of this, right? Your application won't change if you're changing the vendor, right? Because the interface is fixed, your application won't have to make any changes, right? So in this way, it is giving you a consistent way of interacting or building, right, those components. How it is consistent that it's only via HTTP standard HTTP REST endpoint, right? That's what I have for Dapr, but let's see a demo for that. So for this, I have created one microservice-based food order application. This food order application I built on Dapr. So it consists of 4 microservices.
There is another question. So there can be a change in the capabilities of different providers. So can we use those capabilities from single unified interface? Related to one component.
So we can use those capability as well. Even I show you the example of that while I'll explaining the demo, right? So, but yeah, you can use those capability as well.
Okay.
So this food order application, so it's very much similar to any e-commerce application. So you can think of it as like Swiggy, right? Swiggy app. So where users search for restaurant, right? Then he or she add food item to cart. Then he places an order, right? So that's very basic application I built on Dapr. So it consists of 4 microservices. First one is order service. It is written in Java. So so order service basically it manages the life cycle of order. Then there is a restaurant service. So it maintains all the functionality related to restaurant, like adding new restaurant, getting detail of that particular restaurant, right? A menu of that restaurant, each menu item prices.
Right.
Okay. Then we have a rating service. So here the rating service is that end user can rate a restaurant, right? It's not a food item, but end user can rate a restaurant.
Okay.
All rating stuff will be taken care by rating service, and it is written in Node here. Then there is a point service. So whenever user places an order, user receives some point, right, which he can redeem in future, right? So that is being taken care by point service, and this is written in Python. Okay. So this table actually shows what all feature of Dapr or what all component of Dapr has been explored in this application, right? So probably it is very difficult to use all the component in a single application.
Right.
So I thought in this application I probably able to use these concerns. Okay, some of these concerns I have already implemented, but some are in progress. Probably in future I'm working on those concerns to implement. And if anyone of you is interested, then you can also contribute. This is open source project. Okay. So I think I'm already running these 4 microservices in my local machine. Let me check. Yeah. So this order service is running, restaurant service is running, rating and point service. Yeah. So all 4 services are running. So let me first walk you through the order placement functionality. Right. So in order placement functionality is so what is happening internally, I'll explain you that. So with that functionality, I probably able to show you three feature of Dapr, right? Three feature, I mean, I'll probably able to show you pub sub routing, and distributed tracing. Okay? So when user places an order, that order get received by order service. Okay? So the first order service receive that order.
Mhm.
This order service internally communicate with the restaurant service via REST API call, okay, synchronous call, to validate whether this restaurant is uh, correct or not, right? And this restaurant service is also communicating with the rating service to fetch rating of that particular restaurant. Okay.
Okay.
So when order service persists the order in database, it raises an event. The event name is order created. A point service is listening to that event. So whenever this event got created, point service get invoked, and it add points to the user account.
Okay.
Okay. So yeah, so this is Jaeger. I'm using Jaeger to demonstrate distributed tracing functionality. So as you can see, so as of now it is in empty state. So I'm going to create a new order. Yeah. So I've created new order. So if I refresh this page, you can see, so this so this distributed tracing gets created, right? For this distributed tracing, I have not written any code in my application. I have not introduced any library in my application, right?
Okay.
This is all being taken care by Dapr. I'll also explain you how this is working. So if you see, this is my order service, right? So whenever order service needs to communicate with other service, say in this case, it needs to communicate with the restaurant service. So instead of directly making call to the restaurant service, it is talking to Dapr, right? Dapr sidecar.
Mhm.
As I showed you earlier, that we have to start that URL with the /invoke, so that Dapr knows that this service is trying to invoke another service.
Correct.
Okay. Actually, before jumping to that, I would also like to show you the command with which I have started this application. So let me first explain me that command. Okay. So this is how I have started my order application. Right? If you see, I have used Dapr CLI to start the application. In the CLI, I first mentioned the application ID. So each microservice needs to be identified. So that identifier I have given as an order service. Then this is a component path, right? In my slide, I have explained you that Dapr gives you independent component, right? So in this directory, I have included only those components which is required in this application, right? So this, if I'll show you this directory as well. So this directory contain only those components which is required in my application, right? I don't have to install all that component. So then there is so this parameter is app port on which my application is running. So this order service is running on 8080 port, and this is a Dapr port. So Dapr port. So this Dapr port is very specifically to this order application. So if you see, if I start, if I look at how I have started the restaurant service, in restaurant service, I have mentioned different Dapr port.
Right.
Basically, each microservice gets its own version of Dapr, right? Sidecar.
So this is the port
And
for
now
the sidecar, right?
This is the port for sidecar, right?
Okay. Correct. Because the main application will be
So
running on the other
my
port,
local
right?
machine,
App port, 8080 and 8081. This Dapr port is
yeah,
basically for the sidecar. Okay.
that's a port for sidecar, correct? So that's how locally you run Dapr. But say if you are running Dapr in Kubernetes, so probably you don't have to mention this port, right? In Kubernetes, there will be a single instance of Dapr. Right? So similarly, if I have to show you rating, so in a rating service, I have given a different identifier. Rating service, same component path, right? Different app port and different Dapr port. And so this command is what starts your application. Now come back to this diagram. So whenever order service needs to communicate with the restaurant service, it called Dapr, right, with this URL. Then this Dapr knows the exact location of this service, right? Then there will be a Dapr to Dapr communication. Then this Dapr communicate with this restaurant service, and whatever the response a restaurant service is returning, that will go back to original caller, right? Order service. Okay. So now, if order service have to raise a event, right? In this case, order created event. Again, it will communicate with Dapr via REST endpoint. This is what I have shown here, right? V1 publish. Again, this is a REST API call. You are not dealing with RabbitMQ or SQS. You are just making a normal HTTP API call.
So this Dapr to Dapr call, this is via what is the mechanism? Communication mechanism?
I think internally they are using gRPC.
Okay.
gRPC.
Okay.
Then it publish message to the vendor. In this case, this Redis. Right? At the subscriber side, right? So whenever this application starts, right, the sidecar correspond to this application have already subscribed to these events, right? So the subscription code we are not writing in our application, but it's the responsibility of sidecar. So sidecar have already subscribed to those events. So whenever this this service publish an event, this sidecar gets notified. Okay. And this sidecar make a API call, right? In this case, I'm showing that it make a post API call to the point service.
Okay.
Again, you are not writing any subscription code, right? You have basically exposed one post endpoint, right? That will get called by your sidecar.
Okay.
So this is how, actually, if you see, all the communication is happening via sidecar, right? Then sidecar is also publishing those information to this Jaeger, right? That's why this Jaeger is able to build a distributed tracing.
Okay.
Okay. If I have to show you the code, right? Yeah. So this is a order controller. So this is what I have invoked using Postman, right? V1 order. This is a post, right? If you look at order service, so in order service, we are making call to the restaurant service, right? If you see, I have used a Feign library to make a API call, right? It could be anything. It could be a REST template, any HTTP client.
HTTP
right? But I have
okay.
Used Feign client. Right. But if you look at the URL, right, I'm not making a. I have used this property here. So if you look at the value of this property, so I'm making a call to Dapr sidecar, right?
Correct.
You see, while starting this order service, I have mentioned 3500. So I'm calling to my sidecar for invoking REST endpoint of service, restaurant service.
Right.
So now, once we save this order, we publish the event, right? So if I have to show you code for that, so this is a basic interface. In the implementation of this interface, if you look deeper, it is again nothing but a simple REST endpoint call, right? So again, I'm calling my sidecar, Dapr sidecar, for publishing an event. So, so I'm using that / publish, and this is a topic name, right? Now, yeah, so this line, correct?
Right.
So let me show you the component as well. Okay. So if you look at this directory, right, Dapr component, which I had mentioned while starting the application. So this is where all the component I have defined, right, correspond to Dapr. So component configuration related to those components, this is defined here. So if I have to show you PubSub component, right, if you see the value of kind is component. So what it is saying that this file is nothing but a component. Okay. So under specification, right, I'm saying this this is a component of type PubSub, but the implementer is Redis.
Okay.
Right. Now this metadata is very specific to this Redis. I think someone asked the same question, right? So there will be a capability varies from one vendor to another, right? This is how you define that capability.
Okay. So in case we use RabbitMQ, the metadata will change accordingly according to RabbitMQ.
Yeah, correct. Yeah, exactly. So if you look at my screen, right? Again, this is a component, right? I have mentioned this kind is a component. It is component of type PubSub, but the implementer is RabbitMQ. Right? And this because this is a RabbitMQ, metadata is specific to RabbitMQ. Now, if you want to use RabbitMQ specific things like routing key, right, exchange, dead letter queue, and all that you can use. So this is a component which I have defined for PubSub. Let's look at the subscription side, right? Even to subscribe to a particular event or to a particular channel, you define that subscription using YAML, right? Now, if you look at this YAML, its kind is subscribe, right? This says that this YAML file is of type subscription, and under specification, we define basically we subscribe to particular topic, right? So here I'm saying that I'm subscribing to this topic order, right? And this is for this service. So point service is subscribing to this channel, right? And using this PubSub, right? This PubSub we have defined in this component, right? Here I have defined name. If you look at name, so this name is nothing but what I have defined here. So now, say in future I want to change to RabbitMQ. I have to change this. That much change I have to do.
Right.
That's a beauty. You can also define routing rules, right? Here I have written like say if order gets created, if order gets cancelled, then make this API call. Okay.
Okay.
And if nothing matches, by default call this endpoint.
Go to order created. Okay.
Order created. So if I have to show you this point service, right? So even in point service, there is no code related to subscription. I have only exposed bunch of REST endpoints, right? So this is the endpoint will get called by Dapr sidecar, right? Whenever order gets created asynchronously, right? So it adds the point. But if user cancel the order, then this point gets detected.
Okay.
Right. So if you see, my application code is very thin now, right? It's a simpler. Size is very less.
Yes.
Similarly, even in a rating service, I believe I have only exposed REST endpoint, nothing else.
Mhm.
So that's what about PubSub and routing and distributed tracing.
Yeah.
So if you go through this repository, I have explained as well as implemented these components, right? State management, secret, auth to authorization code, right? Rate limit. Yeah. So in state management, yeah, I think we have time. I'll also go through this state management.
Mhm.
So to explore the state management functionality of Dapr, what I have done, I have introduced the order cancellation functionality. So in order cancellation functionality, user is allowed to cancel the order, but within 10 minutes, right?
Okay.
So after 10 minutes, he won't able to cancel the order. He will get an error, right? To implement that in Dapr, what I have done. So in Dapr, Dapr state store, right? I'm storing order ID with the TTL of 10 minutes. So here TTL means time to leave,
Yes.
right? So this value will remain in state store only for 10 minutes. Once 10 minutes expire, this value gets vanished, right? It gets removed from the state store, right? So now when user yeah, application, let me show you. Okay. So this is the endpoint for cancellation. So if user tries, okay, sorry, before that, yeah, when I create an order, right, I'm storing that order ID
Okay.
into state store. So this state store is nothing but a wrapper service I have written, but the underlying implementation is again same HTTP client. Right? So to create a new state, you make a post API call to your sidecar.
Okay.
It gets stored, right? Even in, yeah. So if probably some implementer give you that TTL functionality, some probably won't give you that TTL functionality.
Okay.
So whatever the additional application want to use, they can use a meta data, right? You see, this information is passed as a metadata. So whoever implementer understands this TTL, they able to give that functionality TTL.
Okay.
So this is how state management is handled. Now there is a secret management. To explore secret management functionality, what I have done, so yeah, so I have assumed, so whenever a user places an order, right, the notification of order created event will also get be notified by it will get notified to restaurant service. So restaurant service is also subscriber to order created event, right? So whenever restaurant service receive that event, we make an external API call. External API call to say underlying restaurant. Okay.
Okay.
So generally, whenever you want to make an external API call, it's outside to your application. There is probably you need to use some sort of API key or basic authentication, right?
Right.
And we generally store those secret or sensitive information in Vault, right?
Right.
So what I have done, so I have used this secret management of Dapr to store this API key and basic authentication. So whenever restaurant service need to make a API call, external API call, it first communicates with this secret component.
Okay.
Right? It fetches the API key and make an external API call.
Okay.
Again, this is a pure REST endpoint call. Yeah, if you see,
Can you zoom in a little bit?
Yeah.
Yeah.
So if you see place order at restaurant, so that's the external restaurant external to our application. We are making the external API call. To make external API call, this application is first fetching the secret from a secret management component of Dapr, right? Again, this is nothing but a REST API call. Get REST. Okay. Now say we want to introduce auth2 in our application, right? We want to protect order service. What we have to do, we have to make a changes to the configuration. What I'll do, I'll start order service with a different configuration. Okay. So key cloak as an authorization server, it's already running in my local machine.
Okay.
So, and I have configured Dapr to use that key cloak as a authorization server. Now, if I try to call, say, this endpoint, this I'm trying to call order get API via sidecar. Okay. Yeah. So what happened? This Dapr sidecar, it checked whether this API, right? I'm invoking this API, whether this API has access token with it or not, right? If it does not have access token, it redirecting me to authorization server, right? So I have to log in to the authorization server. Once I logged in successfully, right, my application will receive a authorization token or access token.
So this token will be used to call the sidecar API, is that right?
No, not to call the sidecar API. So basically, this key cloak is protecting your application, right? It's not a sidecar, but your application. So if anyone try to call your application endpoint without authorization code, right? Then Dapr sidecar will stop you, right, from doing that. It will ask for a access token. If you don't have access token, right, it probably redirect you to the authorization server where you have to authorize yourself. Once you authorize successfully, redirect it back to your sidecar. Then your sidecar will deliver that access token to your application.
So is it possible to call the sidecar API without authentication? I mean,
yeah, it is actually without authentication only. I have configured in that way.
But isn't that a problem? Like anyone can call the sidecar APIs to, like, let's say, publish some event. I mean, it needs to have some authentication.
Yeah. Generally, yeah, correct. You are correct. But generally, so there will be a gateway layer on top of that, right? In your whole architecture, there will be API gateway, right? Like a Kong or similar to that, which define which API are exposed, which API are publicly exposed, right?
So the sidecar APIs are not exposed to public.
It won't be exposed to public. Correct.
Okay. Yeah.
But for demonstration purpose, I'm calling that sidecar API just for demonstration purpose.
That's fine.
But yeah. Now, so once user authenticates and authorize himself, right? Then my application will get a access token. If you see in a header, right? I have written a code that fetch authorization header and print that access token here. When in logs we can see we get the this is a authorization code. Sorry, access token, not authorization code. This is the access token, right? So in our application, we have not written anything, right, related to auth 2.0. If you are aware, right, their authorization code, there is a authorization dance, right? It dance from one authorization to the client, then client to the your application server. So that's all being taken care by Dapr.
Okay.
So yeah. So again, if you want to implement a rate limit, again I start application with a different configuration. So let me, I forgot to show you that configuration related to authorization code, right? If you see, its type is auth2, and here I have mentioned all required parameters for auth2: client ID, client secret, what scope is required, right? Token URL, redirect URL, all. You have to configure that component. That's how I have configured. Okay, now say you want to implement a rate limit in your application. Again, you just start, or you change the configuration, right? I'm starting the application with a different configuration. You see, this configuration is a rate limit configuration. So as a rate limit, I have defined 2 requests per second. If caller tried to call my application more than 2 RPS, then he will receive this error.
Okay.
Yeah. So now I will try to hit this API more than 2 times per second in a second. Somehow it's not working again. Anyways, I think you get the idea.
Yeah.
So as I have shown in this demo, right, I have not made any changes to my application, but still I'll able to achieve rate limit, authorization, right? And there is a very consistent way of managing state, managing secret, right? No code for distributed tracing, and very consistent way of achieving PubSub routing, right?
So basically, any kind of distributed mechanism, we have uniformed it with the help of Dapr.
Right, correct. Yes.
Yeah, that's pretty cool. Yeah.
Yeah, these components they have given us, right?
Yeah.
And also some of the implementer are still in beta or alpha stage.
Okay.
Status.
Yeah, that's what I was asking.
Some are ready to be used in production.
Okay.
Yeah. So if you check their website, so they have listed down the current status of each implementation.
Okay.
Right, and some of those implementation is done by Dapr itself, and some are given by community. Right?
Okay.
Even as this is a open source, can also contribute.
Yeah.
So I guess that's all I have for today's session, and probably I hope with this session you get sufficiently motivated to explore Dapr, right? And probably you want to introduce in your application.
Okay, there is one question by Pankaj. Okay, so there are 4 questions actually. So first one is like, how does one go about trying Dapr?
Okay. As such, they don't have a playground, right? Generally, most of the framework or like they have a playground where you can explore a framework or tool, but they don't have a playground. But they do have a quick start, right, type of application, small application, right? Or even you can use this one.
Okay. Yeah.
See, the problem I find in their quick start that they are very basic, right? They are not exploring a complex scenario, but this application, what I'm trying to do is I've used a bit complex scenario and tried to implement that scenario in a Dapr. So probably that could be a starting point for you.
Okay. So the other question was, the vendor specific setup needs to be configured in the application. I think, yeah. I mean.
Yeah, it won't. You don't need to set up in the application. So first of all.
So basically, the question is regarding like if I am already using RabbitMQ for my PubSub implementation, and I want to try out Dapr in that application, so I'll have to make some changes in the application to install the sidecar and all.
Yeah. Correct. That then you have to make some changes to your application. Correct. Because in your application you probably have written a configuration layer, you probably have introduced a library, then you have to remove that.
Right.
Okay. And even in this slide I forgot to mention, I have also mentioned, so when is the appropriate stage of the application to introduce Dapr, right? So if you are starting up a new project, right, and that project is into microservice, then definitely we can at very early stage we can introduce Dapr.
Right.
If you are migrating from monolith to microservice, then probably you can introduce Dapr in your application, right? And say if some of common concern has not already implemented in your application, then probably you can also have a look at Dapr. But if say you have already implemented most of the concerns, right? Mostly we are using New Relic for distributed tracing, right? As you mentioned, if someone has already set up PubSub, right? Then probably Dapr won't help, right?
Okay.
Yeah, it helps in future perspective. Like if you are thinking that in future there is chances of changing the vendor, right? Then probably it can help.
Yeah. Okay. So in a multi-pod setup, the Dapr sidecar will be part of each pod of the service.
Correct.
In this case, the Dapr will transparently connect to pod in a stateless manner.
So your application, let's assume these two pod, right?
Mm-hmm.
You are running two pod of same application, right? So this is a order service.
Mm-hmm.
So order service have to talk to their own sidecar, right?
Correct.
This order service will communicate with this sidecar, and this sidecar will communicate with I have not shown in here. Will communicate with the master node of Dapr, right?
Okay. Yeah. So the question was more. The question was mostly regarding like, will it transparently connect in a stateless manner? So I mean, do I need to pass any state data, or it's mostly stateless?
So it will be stateless, right?
Yeah.
Anyways, whatever the state you are storing, right? Say, let's take the example of that order cancellation, right? The first request comes to this pod, right? This pod is storing that order ID in this Redis, right?
Yeah.
Now let's assume cancellation API will come to this pod, right? Now this pod is again connecting to this Redis,
Right.
So yeah, the state is stored, shared actually. It's shared across the same instance, multiple instances of the same application, right? As an application developer, you won't have to write any code thinking if multiple instances run, what will happen, right?
Yeah, I hope all these questions are answered.
Yeah, great. I mean, still, if you have any question, any doubt, you can reach out to me.
Yeah.
Right, I'll probably very happy to help you out.
Sure.
As a feedback, I wanted to show you that. So generally, this InfoQ releases one page where they show you what's the maturity level of a particular tool. Right?
Okay.
So in this year, it moved to a mature level, right? So it is saying that it is okay to use Dapr now.
Okay.
Okay. Yeah. Sorry. So this is the report I was talking about.
Okay.
So last year it was in this category, innovator, right?
Okay.
This year it has moved from innovator to early adopter.
Okay.
So it's not in early majority or late majority, right? It's still
in
in
the early adoption mode.
Yeah, people are adopting it,
right.
But I'll suggest you still hold, right? Don't use it in production environment,
Correct.
right? But you can start exploring it. You see if there is any advantage of using the Dapr or not, right? Once we see majority of people are using it, then probably we can introduce in our project.
Production. Yeah. Sure.
Yeah.
Okay. Okay. So thanks, Hemant. Thanks for this informative session. I found it very insightful.
Yeah.
And thanks everyone for joining.